In this video, I wanted to discuss the concept of static equilibrium. I have touched upon this briefly in previous videos, but this will be a more in-depth explanation. In my video on tension, where a box was suspended in place by two ropes, I showed how the sum of the forces in both the x and y directions must always equal 0. Understanding this concept allowed us to find the individual forces in each rope. We also know that any object resting on a surface is in static equilibrium. This is because the normal force will cancel out the force due to gravity on the object, making the sum of forces equal to 0. Let's now look at another example involving a seesaw. Suppose that two objects of equal mass are placed onto this seesaw. One object is placed a distance from the pivot point, which is equal to x, and the other object is placed a distance equal to 3x. Let's say for this example that the seesaw is massless. We know that there will be a normal force exerted by the pivot equal to force A plus force B. This might look like another case of static equilibrium, but is it? We do know that the net force in both the x and y directions is equal to 0. However, that's not all that's required for static equilibrium. Each of these objects applies a torque around the pivot point, and since the objects are of equal mass, but object A is further away from the pivot point, we know that it will apply a greater torque. So there's going to be a net torque in the counterclockwise direction. So while the first two examples are in static equilibrium, this one is not. In this example, there is no net force present in any direction, however there is a net torque. So for an object to be in static equilibrium, not only do the sum of the forces in the x, y, and z directions all need to equal 0, but there also can be no net torque. Understanding static equilibrium is important for solving a wide range of physics problems. This allows us to determine the forces present within structures. Since buildings are static structures, these equations can be very useful in their construction. Be sure to watch my next video where I'll go over an example problem. If you found this video helpful, please give it a like or comment below if anything is unclear. Thanks for watching.